Okay, I am going to record test 2, chapter 4, 5, 6. It says student have already taken or started taking, so it doesn't matter. I'm not changing anything here. All I'm going to do, read the questions and cover some answers. So, let me see. I have opened editing version. That's why it's giving me that information. Because if I would go through preview version, the answer won't see at all. So, and we can't check it right or wrong. So, I did my best. Anyway, so the first question: which of the following cannot be a probability? So we need these answers to see so we can say. Before I will go through them, let me tell you, probability can be from 0 to up to 1 portion wise, or 0% up to 100% inclusive. Okay, more than 100% it cannot be. It's a different story when you take 100%, add so many percent, but that's a result of calculation. But other than that, it cannot be more than 100%. It can be decimal notation, it can be percentage notation. So let's go. Possible answers. What cannot be here? 1 absolutely can be. It's 100%. Portion wise is 1, percentage wise is 100% times 100. 1 times 100, 100%. 75% can be. 4 over 3. This one, why it cannot be? It's a correct answer because it says cannot be a probability. Cannot because 4 over 3 is a 1.1 and 1/3, right? Or 1.333. It's over 100% over 1. That's why it cannot be. And 0.0002, that's going to be if I multiply by 100, meaning moving 2 zeros to the right and getting 0.02, 0.02%. 0.02%. Okay? All right. Moving to question number 2. Let me open this one so we can see the questions. Well, here is also 105. Okay, the other thing also I can add that cannot be probability. It's a negative number. Whatever type it's gonna can be between 0, 1, over 1. As long as it's negative, it's wrong. It cannot be. Okay. So moving to next question number 3. Okay, what do we have? A bag of candy was opened and the number of pieces was counted. The results are shown in the table below. So find the probability that the randomly chosen piece of candy is not blue. How many blue we have? 15. So what we're gonna do? One way is I'm going to summarize total. I took a picture of it so I don't have to go forth and back. So red is 25, and then 20, and then 20, and then 15, 10, and 10. This one is blue one. We need to eliminate the blue one. So two choices. First of all, let's get the total. 5 and 5, 10. 1 in mind, 2, 4, 6, 7, 8, 9, and 1 is 10. So 100. Total we have 100. So two choices. We either can find probability of blue, which is going to be 15 over 100. So that is 0.15. And then since we total is 100 is 1, right? I'm doing 1 minus, so probability of not blue. 1 minus 0.18 and we are getting 0.85. And the other way is add this 25, 25, 20, 20, 10, 10. And it's going to be total 85. We take 85 over 100 and it's going to be 0.85. Moving to our answer. So let's see. 0.85. Okay, very good. Moving to next question. Moving to number 4. Okay. Here what we have. So it's given table and the question is as follows. If we randomly select one manager from this company, find the probability that he or she has an advanced master or PhD degree and keyword and remember and or is a good manager. So where is the intersection between master or PhD and good manager? It's 1 here, right here. This is this one. And our overall total is 160. Let's go check. There we go. Moving to next question. Here it is. Some numbers are missing, so we need to fill in. In this case, it's going to be number that is missing under letter A, letter B, and letter C. So what is it? We have here total at the last row, right? So it's summarizing male and female from group 1, group 2, group 3, and a total of the column total shows overall of male in all groups, overall of female in all groups. It's easy to find out. So group 2, if let's say you want to find the total, the column group 2, the under letter A, you have to add 21 and 30. If you want to find the group 3, there are 2 ways. So either you take 38 to minus 21, calculate in the column, or you can go in the row, let's say, male for the total is 120 minus 21 minus 82. Males in group 2 and group 1. Very easy. And C is a total, grand total, practically total over total. So you either can go by column, 120 plus 80, or you can go 111 plus whatever you have under A, letter A, which is 51, and plus 38. You should get again 200. Okay? Pretty straightforward. Moving to next question, number 6. Okay, here it is. Let's see what we have here. Researcher investigated, okay, the whole thing, I'm not going to read, just the table already given. I'm reading question. Given the person sitting in area 1, the front, middle portion of the class is randomly selected to answer a question, okay? Find the probability that the person selected is female. Okay, from A1 class, given that person sitting in area 1, the front, middle portion of the class is randomly selected. What is middle option? I guess I have no choice. I have to go back and read. So, researchers investigate whether a student's seat preference was related in any way to the gender of the student. The researcher divided the lecture room into 3 sections. Area 1 front, middle of the room, area 2, that's what it means. Okay, middle portion of the class. All right, so we are going to work with area 1. So given area 1, sitting in area 1, we need to find the probability that person selected is female. Since the area 1 is given, so our total is going to be total of area 1, not overall total 72. Okay? And if we want to find probability of female, it's going to be 13 over 28, because in area 1 we have 13 women, and total in area 1 is 28. And we forget about grand total, because it's already mentioning where to look for. It says area 1. Let's check it. 13 over 28. There we go. Bingo. That was question 6. Moving to question 7. Here we have question 7. So we have a table, and let's see. Find the probability given that no, the selected student is in senior class. See, it's already mentioning is given in senior class, which means this total senior, which is amount, which is 35, it's going to be already your total. That's already hint for you. Find the probability they drive a domestic automobile. Domestic is 10 out of 35. There we go. That was question number 7. Moving to question number 8. Okay, so which of the following can be considered a probability distribution? Here we are given. How we gonna figure it out which one considered probability distribution? If it's probability distribution, total is gonna be 1. If you add here first one 0.1 in 0.506 and then 0.9 and 1. So okay, so that's why it's correct. The other correct 2 choices there. Also, it's also getting 1 here. But here you have negative, that's already we are throwing out a window. And this one, the last one, we get 0.4, 0 plus 1, 0.5, 0.7, and then 0.8. So this is not a probability distribution. So you have to add them up and get 1. That's why. Okay, so that was question number 8. Moving to question number 9. So what do we have here? Determine probability distribution is missing value. Well, this is easier than it you would think. So probability P of x 0.12, 0.52, and including probability that is missing, if you add them up, it's gonna be 1 portion wise, right? Or 100%. So what you're gonna do to find this missing probability for x is equal 4, you take 1 and subtract all these probabilities. 1 minus 0.12, 0.52, or add them up and then subtract from 1. And you are going to get how much? 0.06. That is question 9. Moving to question 10. Which one we gonna okay, maybe this one. So state whether the variable is discrete or continuous. The temperature in degree Fahrenheit on July 4th, Alaska. So degree is always going to be continuous because degree can be with any decimal notation, right? Therefore, it's always going to be continuous. Discrete are going to be the cases when you can count them. Continuous, you can't count. Just like water, you cannot count. What else we have here? State whether variable discrete. The fluid ounces. Now this one is interesting. Oops. Fluid ounces. This one is going to be, let me see, continuous also, because you have fluid. It's a water, I just told you. Okay. I think enough of this type of questions. Number of pills in container of vitamins. This one is definitely going to be discrete. Let me open the answer, because you are going to count. There we go. Okay, that was question 10. Moving to 11 also, same continuous discrete, and we already solved it, did it. 12 also the same way. Moving to question number 13. Okay. What do we have? Question number 13. are giving you matching. We need to match it up. So based on empirical rule, and I have a lecture, if you go to statistics underscore lecture, you will find it there, empirical rule, if you want to read it and understand. If somebody cannot find that playlist, lecture underscore, no, statistics underscore lecture, if you can't find it in among my playlists, just contact me, I will let you know. So what means approximately 68%? 68% meaning plus minus 1 standard deviation. 95 plus minus 2, that's how you identify normal distribution. If your distribution normal, then data within 68% starting from the mean between, so it's 68%, that means 34% to the left, 34% to the right. Let me show you here. This is what I mean. This is your mean, x bar or mu. Mu is for population, x bar is for sample. So 34% here, 34% here, right? And they have to be minus 1 standard deviation plus 1 standard deviation, okay? And then 95%, and that's 68%. And then 95%, it's going to be within 2 standard deviation, and so on. And 99.7, I believe it's going to be 3 standard deviations. 99, oh, oops. Where is it? Oh. Here it is. And 99.7% is plus minus 3 standard deviation. So from average mean plus minus 3 standard deviation, it will include 99.7. Why is not including all 100%? I have already mentioned it, that statistics never guarantee 100% anything. This is as high as it can go, 99.7%. Okay, this was question number 13. Moving to question number 14. Here it is. We have answers already. I opened, so let's solve it, and then we can check. A small company. Oh, okay. This is regarding our empirical rule, the one we previously did. So it's asking 95% how much it will be. Mean is 84. Remember what we said, 95% plus minus 2 standard deviations, right here. So we are going to, what you are going to take, 84, and you have standard deviation 9. Since 2 standard deviation, it's going to be 18, right? 2 standard deviation. And then you're going to do 84 plus 18, 84 minus 18. So 80, where is it? 84 minus 18, it's going to be 60, yeah, 66 and 102. So minus 18 and 84 plus 18. Okay, so that's number 14. Moving to number 15. Okay. Use the standard normal distribution to find probability Z greater than 0, less than 125. Here we are going to StatCrunch. Here it is. So we are clicking Stat and then choosing Calculator, and we are choosing Normal. So here it is. If in your word problem it's not given the mean and standard deviation, we always going to use mean 0 and standard deviation 1. Since we are given in between, I'm choosing here, clicking between. There we go. So it's going to be here 0. And here we said 1.25. 5. And we click compute, and we get 0.394. Okay, let's go back. 0.3944. Okay, 4 digits. All right, that's okay. Coming back. 3944. Well, why is it 4? Because this behind of 3, it's you have 5. If you round it, 3944. Okay, we are good. So moving question number 16. A physical fitness association is including the mile run in its secondary school fitness test. The time for this event for boys and secondary school is known to possess a normal distribution with mean 460 and standard deviation 60. Okay, 460, mu is 460 and the standard deviation is 60. Okay, what do we have here? So find the probability that randomly selected boy in secondary school can run mile in less than 322 seconds. That is going to be our x, less equal 322. What we're going to do, we are going to find our z-score, which is going to be equal, z-score is equal, x minus x bar or mu, probability population mu, sample x bar, and divided by either S or sigma. S is standard deviation for sample and sigma standard deviation for mean. I'm not going to go back and read which one they want because it doesn't matter. Same numbers we are going to use anyway. So it's going to be 322 minus, let me use different color. This one is formula right now. I'm going to use this. 322 minus mean 460 and divided by 60. So what do we get here? 322 minus 460, and we are getting here negative 138, and dividing by 60 we are getting negative 2.3. So we have z-score negative 2.3. All right, now we are going to go to our StatCrunch. So z-score is going to be, it's not in between, it's less, so we are using standard. Okay, so, and we are using less than because it says less than, and it's going to be, let me see, clean it. It's going to be negative 2.3, and we are getting 0.011 if I round it up. Let me see. 0.0107. Okay, let me see why we didn't get 07. 0107 indeed. Okay, now if it says less than, but what if it will ask you more than? In that case, you're gonna flip. See, it shows less than. So you are flipping here, so clicking more than, and it will show the red portion, and it's gonna be 989, blah blah blah. Or once you get your less version, so you take 1 and subtract 0.0107, that will give you right portion. Okay, either way. So this was question number 16. Moving to question number 17. Here it is. Grades on, is this, yeah, there are answers. Grades on molecular biology exam are normally distributed with a mean, it's given x bar, and standard deviation s. Okay, find the probability for a student score greater than x. Okay, here are a bunch of versions are given, but I'm not going to go over because all answers are open there, the ones you're gonna get. So therefore, you are solving exactly same way. So you are taking x, whatever value of x is going to be given, subtract value of x bar. On your test, you are not going to see x bar and x. You're going to see numbers, real numbers, okay? So you're going to take x minus x bar divided by s. Take the numbers, divide, get your z-score, and go to StatCrunch. Since here it says greater than x, then you just flip the sign on StatCrunch, greater than, and you get the result, okay? So moving to next question. What is this one? Okay, here it is. The threat life is in particular brand of tire is random variable, best described by normal distribution with mean 60 and standard deviation 2900. Same story. So we have mean, we have standard deviation. We need to have also, it's asking what warranty should the company use if they want the top 96 percent. So warranty is given. No, warranty we need to find. Top 96%. So what we're gonna do, we need to find z-score for that top 96%. And it's gonna be top 96 meaning greater than, right? And percent, I plug it here. It's going to be 0.96, right? 96%. Click compute. And here is my z-score negative. Where is it? Yeah. It's negative 1.75060. Negative 1.75. Okay. So negative 1.75. So you have z-score. Let's work on it. So z-score equal x minus x bar over s. Now we need to find x because x is not given. So we are getting here zs is equal x minus x bar. And x, oops. And x from here is equal x bar plus zs. So let's see. We have everything. Z-score, we already have it. How much I said? Negative 1.75. And then we have mean 60,000 and deviation 2,900. You plug in and you get the result. So let me see. Okay. 60,000, 2,900. 60,000, 2,900. And this one, negative 1.75. So let's see, I'm going to 2,900 times 1.75. I'm getting negative, because it's negative, 5,075. And 6,000 minus 5,075, I got 925. Okay, let's see. It's kind of big number. Maybe it asks for days. Let me see. 54,925. Let me go back. Doesn't work. Let me go back again. Let's double check again. 2,900 and 60,000. Oh, hold on. 60,000. I took maybe 6,000. Yeah. Minus 5,075. There we go. I got it. I used 60,000. I lost 1 0. And it's going to be 54,925. Bingo. Okay. 54,925. And the last question, we are going to solve it. Number 19. Oh, this is this graph. So what is asking? What is the question? I don't see here question. Determine whether the following normal probability plot indicate the sample data that could come from a population that is normally distributed. I would say no, because if you provide line, it goes like curve. Let me open the answer. Where is the answer here? Not approximately normal distribution. Okay? Okie dokie, we are done. Thank you for watching.